1.2 More concept. Learning outcomes. Define the terms empirical and molecular formula. Determine empirical and molecular formula from mass composition or combustion data. Mole. The mole is the unit of measurement for a mole of substance in the International System of Units. For example, a dozen of roses equal to 12. A pair of shoes equal to 2. So, do you know what is the number represented by a mole? A mole equal to 6.02 times 10 to the power of 23. This number also known as the Avogadro constant. This diagram shows the interconversion between the mass of elements, number of mole of elements, and number of atoms of elements. For example, mass of element divided by its molar mass to get the number of mole of elements, whereas the number of mole of elements multiplied by its molar mass to get back the mass of elements. In order to get the number of atom of element, we need to use the number of mole of elements divided by its Avogadro constant. Based on the diagram, you notice that all the calculation must go through moles. Now we proceed with a simple example with the simple calculation by using the mole concept. What is the mass of 1 mole of ammonia gas NH3? To convert the number of mole to its mass, we need to use the number of mole multiplied by its molar mass. The molar mass for NH3 is 17. So 1 mole of ammonia gas equal to 1 times 17, that is 17 grams. How many molecules are ammonia NH3 present in 1 mole of ammonia gas? To convert the number of mole to the number of particles, we need to use the number of mole multiplied by the Avogadro constant. So since we have 1 mole, means the number of molecules of ammonia gas is 6.02 times 10 to the power of 23. What is the number of the hydrogen atoms that present in 1 mole of ammonia gas? By checking the molecule of ammonia gas, 1 molecule of NH3 contains 3 hydrogen atoms. So if 1 mole of ammonia gas NH3 must contain 3 mole of hydrogen atoms. So we use the number of mole of ammonia gas times Avogadro constant times 3. So the answer is 1.806 times 10 to the power of 24. Last, what is the volume that occupied by 1 mole of ammonia gas at STP, standard temperature and pressure? At standard temperature and pressure, any gases, if 1 mole must occupy 22.4 dm³. So 22.4 dm³, also known as the molar volume. Since we have 1 mole of ammonia gas, so the volume is 22.4 dm³. Do you know what is the difference between the average atomic mass, relative atomic mass, and molar mass? Let's go through one of the examples. For carbon 12, C12, average atomic mass is 12.00 AMU. Relative atomic mass equal to 12.00 and molar mass equal to 12.00 gram per mole. So from this example, we can conclude that average atomic mass, relative atomic mass, and molar mass have the same numerical value but only difference in its unit. Empirical and molecular formula. Empirical formula is a chemical formula that shows the simplest ratio of all elements in a molecule, whereas the molecular formula is a formula that shows the actual number of atoms of each element in the molecule. Molecular formula equal to N empirical formula. Empirical formula can determine by mass composition or combustion data. For example, given the two compound, the first one, where we have 1, 2, 3, 4, 5 carbon and 10 hydrogen. So C5H10 is the actual number of the atoms that present in that compound. So C5H10 is the molecular formula, whereas the empirical formula for it is CH2. So CH2 is known as the empirical formula. Example: a sample of hydrocarbon CSHY contains 85.7% of carbon and 14.3% of hydrogen by mass. Its molar mass is 56. Determine the empirical formula and molecular formula of the compound. To get the empirical formula, first we need to construct the table. Hydrocarbon means the compound only consists of carbon and hydrogen. In order to get the empirical formula, we need to have the mass, number of mole, and the simplest ratio of the mole of the elements. Based on the questions, we know that the mass of carbon is 85.7 and the mass of hydrogen is 14.3. Convert the mass into the number of mole by divided its atomic mass. So you get that the number of mole of carbon is 7.14, whereas the number of mole of hydrogen is 14.3. Compare both of the number of mole. Since the number of mole of carbon is smaller than the number of mole of hydrogen, so to get the simplest ratio, we need to use the number of mole divided by the 7.14. So carbon, the ratio is 1, whereas the hydrogen, we get the ratio is approximately to 2. Empirical formula CH2. Molecular formula equal to N empirical formula. And we know that the questions given the molar mass is 56, means 56 equal to NCH2. Atomic mass for carbon is 12 and for hydrogen is 1. So you have 56 equal to N14. So N equal to 4. Finally, you get the molecular formula equal to C4H8.